In number 2 here, someone in the other class said, Mrs. Carter, I got my exponent wrong because I thought that when I'm changing my standard form to a smaller number, my exponent is negative. And I said to her, that's not what you're attaching to the sign of your number, your sign of your exponent. What am I looking at when I changed 555,900,000? When I change that into scientific notation, what number dictates the sign of the exponent? What number, Hannah? The standard form. Which number is the standard form number up there? That really big number. So I do not want you saying to yourself, okay, I had to make this into a smaller number so that exponent's positive. That is not what I want you doing. That's going to get confusing. Remember from the very beginning on Monday when we started this, I said to you guys, we are going to be attaching the sign of the exponent to the size of the standard form number. And I need you keeping that in your head and using that as your guide. Okay? Okay, what problems can I do for you from last night's homework before we move on? Jacob? Number 9? Okay. All right, if I take a look at number 9. Number 9 said I have 2.104 times 10 to the negative 8th. All right, so Jacob, what is the sign of my power on my 10? So this is negative. All right, since that is negative, what does that mean I have to change my first factor to? Do I need to change it to a really small number, or do I need to change that first factor to a really big number? Yes, so this negative means that I need to change the first factor to a really small number. That's what that exponent means, is that I need to change that first factor to a really small number. If you made a mistake on this and you made it bigger, I need you making a note just like that in your homework. So make this note if you got that wrong. All right, so I have 2.104. So I have to make it into a really small number, Jacob, so that means I'm moving to the left. Would you agree with that? How many places am I going to move to the left then, Jacob? 8. Yep. So 1, 2, 3, 4, 5, 6, 7, 8. Give yourself room on each of those little moves. Joseph, you're paying attention. Give yourself room on each of those moves so you can see where the zeros are. So I'm just going to put a 0 into each of these. So I end up with 0 point where there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 2, 1, 0, 4. Jacob, does that help you? Awesome. Alex? Yep. But if I take a look at number 7 said Pluto is 5 billion kilometers from the sun. All right. It said, write this in scientific notation. Well, Alex, to do that, you first have to write that in standard form. So if I have 5 billion, how many zeros does that mean are going to be on the end of that? It means there's going to be 9. So 5 and then 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. All right, so, Alex, my decimal right now is at the very end, correct? So I need to move it between the 5 and that first 0. Would you agree with that? So I have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So that's 9 places. All right, so it's going to be 5 times 10. It's a ninth. Is that going to be a positive 9 or a negative 9, Alex? Why is it positive? Excellent. All right, put this away, get your notes out. I have one new thing for you. All right, so we are still in 4.9. We're still talking about scientific notation. So what we're going to be focusing on today is we're going to focus on writing numbers in what I'm calling proper scientific notation. That's what we're focusing on today. Proper scientific notation means that it meets the requirements for scientific notation. So let's talk about what that proper scientific notation is. So if I look at my first factor, when I look at my first factor, one digit in front of the decimal. So these are the qualifications, the requirements. One digit in front of the decimal. Any number of digits after the decimal. All right, then we have our times. And then our second factor is 10 to some power, and that power can either be positive or negative. So this is the proper scientific notation, is in that format. And that's what you guys have been changing the standard form to. How many of you guys are cool with that so far? All right. We today are going to be focusing on that requirement. Who needs to see what's up there? So that's just a review of what we already know. Okay. So here's my first example. All right, I'm going to show you some steps off to the right, and I'm going to do this example to the left. So I want you to change the following number into scientific notation. When they say that, they mean proper scientific notation, because when I show you what we're doing, you'll understand what I mean by that. So my example is 0.37 times 10 to the 10th. Why is this not in proper scientific notation? I mean, why am I saying change this into scientific notation? It looks like it is in scientific notation. Why is this considered not in scientific notation? Sophia? Yeah, I need to fix that first factor. So we need to fix the first factor, because that is not in the proper form. All right, so here's what we're going to do. I'm going to do this part of it in blue. My first step is we want to change the first factor into scientific notation. Now, I know that we already have that times 10 to whatever power there, but I'm setting that aside. All right, I'm just going to take the times 10 to the 10th, and I'm going to set it aside for now. I'm going to say set aside. So just set that times 10 to the 10th aside. All right, so what I'm going to do here, I'm going to rewrite this, I have 0.37. Someone change that into scientific notation for me. I just want you thinking about this. Someone change this into scientific notation for me. Lawrence? Excellent. And what do I end up with? 3.7 times 10 to the what? 10 to the 10th. How many places did I move the decimal? Positive or negative? Is my standard form small or big? So this has to be negative. So there is that number in scientific notation. You guys good with that so far? Okay. I'm going to do this next part in red so you can see this. My second step is you're going to put the new first factor back with the original times 10 to the 10th power. So now I'm going to put that back together. So I'm going to put our new 3.7 times 10 to the negative first, and I'm going to put it back with my 10 to the 10th power. So what I did is I changed my first factor so that 3.7 is in the right form. Questions so far? Yes. Put the new first factor back with the original times 10 to the 10th. All right, the last thing I'm going to do is I'm going to use the multiplication power rule to simplify the tens. Sophia, what's wrong? So the x times 10 to the 10th power, I'm just setting it aside. I'm just going to set it aside. And I'm going to put it back with that first factor once I change it into scientific notation. Are you cool with that? All right, so the last step. So now instead of 0.37 times 10 to the 10th, that's the same thing as 3.7 times 10 to the negative first times 10 to the 10th. So now I'm going to use my multiplication power rules to simplify that to the 10 to the first, negative first times 10 to the 10th. So I have 3.7 times 10. When I'm multiplying two numbers with the same base, what do I do with my exponents? Francesca? You add them. So I have negative 1 plus 10. So this is 3.7 times 10 to the 9th power. So I'm going to quickly walk through this again, and then we're going to do another one. That first factor is the problem. It's not in the proper form. So I'm just going to take that first factor and I'm going to turn it into scientific notation. And then I'm putting it back with the original scientific notation and I'm going to simplify. Let's do another one. So I have 453.1 times 10 to the 8th. And I want you to put this into scientific notation. All right, so I'm going to take my first factor and I'm going to turn it into scientific notation. What am I going to do to change 453.1 into scientific notation? What do I do, Francesca? Excellent. So I end up with 4.531 times 10 to the second. Positive or negative? Why? Yeah, this 453.1, that standard form was big, so that's positive. Jagger, are you good with this? Okay. So now what I'm going to do is I'm going to take my 10 to the 8th and I'm going to put it onto this. So I changed my first factor into scientific notation. That's what this is. and then I'm putting it back together with the original times 10 to the 8th. Questions so far? Ava, are you good with this? Awesome. So now I'm going to use my power rules to simplify at 10 to the 2nd times 10 to the 8th. So I have 4.531 times 10 to the, well, I'm multiplying two numbers with the same base. I keep the base, and Evan, what do I do with the exponents? Yep, so I add 2 plus 8. So I finalize this by saying 4.531 times 10 to the 10th power. Okay, so listen to me. 4 through 17 are 4 problems of doing that, okay? I'm going to be bringing you a worksheet that has more of that on it. Do you guys understand? So you're going to come get a worksheet from me by the end of the day that has more of these types of problems on there. Please use these notes as a very strong guide for you when you're doing these, okay? All right, you guys can go.